let's look at the difference of these two equations. Because they have the same numbers, but the graphs would be very different. We're going to plug in some values after we describe each one with hark. The herald angel is singing. Okay, so first off, horizontal translation would be what's on the inside. So this would be moving it to the left because my vertex is -2. -2 is to the left. So this is a horizontal translation left 2 units. Then we have a dilation. That would be our A value. Yes, we have a dilation here, and it's on the outside, so it's going to be a vertical. And I know it's a compression. So vertically, we're compressing it towards the x-axis. So instead of going up like this, we're going to be pushing it down and making it like flatter, like that. Okay, and then is there a reflection? That would be if I see a negative A value, and I do have negative. So this is a negative vertical reflection. Do you know why? Because it is on the outside of the parentheses. It is after the function, after the absolute value operation. So vertical reflection across the x-axis. So this equation will be pointing down, or opening down, I guess, and maybe pointing up. Opening down, like that. And then finally, let's look at the vertical translation. Very last part, we have down 3. So down 3. Great. Okay, so we're going to graph that in a moment, but this is that one. Okay, now let's go back through. I want to try and color code the same way. Green is going to be my horizontal translation. Do we have a horizontal translation? Yes, we do, and it is going to be left 2 units. Dilation, okay. Here we have this, and this is on the inside. So this is going to be horizontal dilation. So I do horizontal, and I know because it is a fraction on the inside, it's the opposite of what it would be vertically. This is a horizontal stretch. So stretching away from the y-axis. So even though we went 2 to the left, it's going to be stretched away from that by a factor of 1/4. So it's actually like quadrupling its distance. Instead of 2 times 4, it's going to be 8. Do we have a reflection here? Look at A. Is it positive or negative? Oh, we do have a negative. And that will be horizontal. Ooh, interesting. So it's not going to be opening down. It's going to be reflected across. So like the V will reflect to V. It's not going to be going down like this. So horizontal reflection across the y-axis, not the x. And then lastly, you can see our vertical translation is also going down 3. Okay, so I'm going to plug in some values to help you see some lattice points to graph. Then when we graph it, you're going to see pretty clearly what transformation happened. So focus on this left thing. All right, so first off, I know the vertex is -2. If I plug -2 in to this absolute value, I get 0. 0 times -1/4, it is still 0, and then -3. This is the vertex of this equation. Okay, then let me pick some numbers close to that. So -3, -3, it's kind of not a great one to choose, too, because then I have a lattice point. Let me try and get a multiple of 4. Yeah, let's do 2 actually. 2 plus 2 is 4. Absolute value of 4 is 4. Negative 1/4 of that is -1 minus 3 is -4. And then let's go, I can do another one like 6. 6 plus 2 is 8. -1/4 is -2 minus 3 is -5. Okay. And if I plug these points in so far, I have -2, -3, 2, -3, so -2, 1, 2, 3. I have 2, -4, and I have 6, -5. 1, 2, 3, 4, 5, 6. Is this wrong? Okay. Yeah, I think I did. Oh, sorry, this is here. Then 1, 2, 3, 4, 5, 6, like this. Yeah. So then I have, this is going this way. Slope is -1/4. And since this is the vertex, I know it's going to be a mirror image. So 1, 2, 3, 4. Yeah. And then that's going to go like this. Ooh, yeah. That is correct. So this one I can see is -1/4 of it. So that's that one. Okay, now let's come over here and try to get some lattice points. So if I have x and y, what would be satisfying? Let's plug in 4 to this. 4 -1/4 is -1, plus 2 is 1, minus 3, 1 minus 3 is -2. Let's try 8. -1/4 of 8 is -2 plus 2 is 0, minus 3. Okay, then try like -4. 1 plus 2 is 3. Sorry, -4. 1 plus 2 is 3, minus 3 is 0. Okay, so now we have 4, -2. 1, 2, 3, 4, -2. We have -4, 0. 1, 2, 3, 4. And I have 8, -3. 1, 2, 3, 4, 5, 6, 7, 8, -3. 1, 2, 3, 4. You can see this is going like this. And my vertex, I can copy this thing from above. Vertex can be found by setting what's inside the absolute value brackets equal to 0. So -1/4 x plus 2 equals 0. -1/4 x equals -2. Multiply by 4. Multiply by 4. Negative x is -8. X equals 8. So I know this is my vertex, 8 comma -3. And then I would just duplicate this going this way. The same amount. Okay. So let's zoom out a little bit and describe them finally to wrap it up. So here we have a compared to the parent function, which is this in both accords. Okay. We have on this one, we went left 2, vertically compressed towards the x-axis, so we squeeze it down. So now it's left 2. It would be by a factor of 4 like this. Then we have a vertical reflection, so it flips over. So now it's like this. And then finally move it down 3. Yep, that looks right. Okay, now go this way. Left 2. Okay, horizontally stretched. So now it's not just left 2, it's actually left 8. Horizontally reflected, right 8. Then finally vertically translated 3 down. Okay, That was great practice. Remember to use that HARC method and to see, remember the song you have. Can I move this? You can't have the same horizontal translation if you also have horizontal dilation. So when I had +2 and +2, did these have the same vertex? No, they did not. Okay. What a great topic. Good job, guys.